In this video, we will measure the turns ratio of a high-frequency transformer. High-frequency transformers are used anywhere that requires a voltage change, like in cell phone chargers and adapters. First, let's look at the structure of a transformer. A transformer is made up of a primary side and a secondary side. A measurer called the core surrounds the middle and the windings. To test a transformer, you typically measure it using an oscilloscope or an LCR meter. However, these are quite expensive, so they are not easy to buy. What is a simple way to measure a high-frequency transformer at home? First off, if you know the part number, checking the datasheet is the most accurate method. But since the one I'm measuring doesn't have a datasheet, I will measure it directly. You need two conditions to measure a high-frequency transformer. First, low AC voltage. Second, sufficient frequency. I introduced it as AC voltage, but more accurately, you need a power source with a specific waveform. This includes waveforms like a square wave or a pure sine wave. A frequency of about 30 kHz is fine for taking the measurement. Now, let's build the circuit. Here's the circuit diagram. I used a NE timer IC to generate the frequency and the power waveform. By following the datasheet, I placed resistors and capacitors to create the desired frequency. There are two measurement points in total, one on the primary side and one on the secondary side. The voltage at the measurement points is read after being run through voltage smoothing using a capacitor. Even though it's a square wave source, the frequency is too high for a multimeter to measure accurately. For more details, please click the blog link in the video description. You can also use a CMOS-based chip instead of this IC. Now, let's do the test. I have labeled the bottom 2 pins as the primary side and the top 2 pins as the secondary side. I limited the power supply to 20 voltage and the current to 5 ampere. First, I'm measuring the voltage on the primary side. The voltage is about 8.5 volt. Now, I will measure the voltage on the secondary side. The voltage is about 2 volt. Calculating this gives us the turns ratio. The voltage measured here is the peak voltage of the square wave. Due to the diode voltage drop, the actual peak voltage is slightly different. This time, we learned a simple way to measure a high-frequency transformer. The turns ratio ratios for various high-frequency transformers are posted on my blog. I have other experiments and DIY projects planned, so please subscribe to the channel to catch the new videos quickly. Thank you for watching.